Right. Ready? So good morning all of you.
Good morning, sir.
The summary of the last lecture, we have discussed this. Acha, right. Free electron theory of metals. So we have successfully completed this free electron theory, which can explain the specific heat of solids. Am I right? Good. Now take a fresh page and put the heading band theory of solids. Band theory of solids. This is a very important, definite question, no doubt about it. Either band theory of solids or a free electron theory of metals, definitely you will get a question, very important, listen carefully. So what is this band theory of solids? First, why they have introduced this? That means what is the purpose of introducing this band theory of solids study? Ready. So till now we have taken free electron theory. Say yes or no? Yeah. Free electron theory. Till now we have discussed. What is the meaning of free electron? That means you are assuming the electron is moving freely inside the lattice. That is nothing but a free electron theory. Am I right? Whenever it is a free, the potential energy equal to 0 and the energy is only kinetic energy, non-relativistic. That's why h cross square k square by 2m. So finally, if you treat the electron is moving inside the lattice as a free particle, its energy is proportional to what? K square. We can say the energy is proportional to k square. Cool. Now I am taking the graph, energy versus k. This is the energy and this is the k I have taken. So one thing is very clear, energy is proportional to k square means the curve is a parabola. Say yes or no? This is the curve we got. If you treat the electron as a free particle, is it a discrete spectrum or continuous spectrum? Continuous. That's good. So we got continuous spectrum. Very nice. So these are the results, I mean till now what we have done in the free electron theory. Then what is the problem here? Let's see. Actually this free electron theory, a free electron theory can explain thermal conductivity, I think we didn't explain this, thermal conductivity and specific heats. This one we explained clearly. Specific heats of solids. Specific heats of solids successfully. It's not a failure theory. It's a successful theory only, by which we can explain the thermal conductivity as well as specific heats of solids. But unfortunately, this could not explain. This could not explain the behavior of solids. What behavior, sir? Yes, some solids are behaving like conductors, some are semiconductors, some are insulators. How these solids become insulator or conductor or a semiconductor, on what basis? So this classification came. This was not explained by a free electron theory. I hope you understand what is the failure of a free electron theory. This could not explain the behavior of solids. What is that? Conducting behavior. How conductors we got? Or next one, semiconductors. Anything? Okay. Semiconductors and insulators. Oh, fine. So why this solid? Iron is a solid. This is also solid. Why this is behaving like insulator? Why iron is behaving like a conductor? What is the reason for that? but this was not explained by free electron. So then they started, what is the reason behind this? Then they thought that actually here we have treated electron is a completely free. But if you observe carefully, this is the lattice point. Listen, this is the lattice point. I mean, these are the lattice points. And at each lattice point you have a ion core. Say yes or no. That too positive ion core. That's why plus Ze. Nucleus plus Ze. Positive ion core means nucleus plus Ze, something like this you have. At each lattice point you have a positive ion core which is affixed to the lattice. Now what you are saying, your electron is moving in the lattice. But if you observe carefully, the electron is moving in the periodic lattice, or it is moving in the lattice where we are having positive ion cores. So the electron is coming close to the positive ion core, again going away, again coming close, again going away, like that. That means this electron is not at all a free particle. It is moving in the potential interaction, or it is moving with the potential interaction of nucleus or ion core. Free means what? Potential is 0. Whenever the electron is moving or coming close to the nucleus, what is the potential here? The potential at the nucleus we can say Ze by 4 pi epsilon naught. Yeah, that potential is there. Then why you are saying a potential is a completely 0? Okay. So now we are going to treat the electron is not at all free. The electron is moving in the periodic potential. Potential is repeating, see, observe carefully. Maybe increase, maybe decrease, but whatever it is repeating after certain intervals. Sir, why that intervals came? Your lattice structure. Your lattice structure is having a periodic behavior. That's why your potential is also having a periodic behavior. That's good. So finally what you understand, actually electron is not free. Electron is not free. Okay. So electron is moving in the periodic potential, of the lattice. 1 second. Okay. So if I assume this, just I am taking one nucleus. This is the potential V of R, potential energy, and this is R. Okay. So everybody know what is the potential? The potential equal to potential energy. I am talking about energy. This is the potential, and electron is moving in that potential. That's why minus Ze square by 4 pi epsilon naught. I hope so. This side no response at all. And here we have the nucleus plus Ze, and the electron is coming close to this nucleus. Then we are having this interaction. Say yes or no. Then the graph will be attractive. That's why negative, like this. So this will be the potential curve at the nucleus. So but its lattice is a combination of so many positive ion cores. That's why we have to assume this is the potential energy, everyone. This is R. I hope you are observing. This is the positive ion core plus Ze, and again this is also plus Ze, and this is also plus Ze. This is also the positive ion core. Something like this. Now if you consider the entire lattice in one dimension, we can't draw 3 dimension, in one dimension, it's look like this. Now your electron is moving in this potential. So what are the potentials? What are the potentials it is experiencing? See, are you ready? So this is the nucleus site, this is also nucleus site, This is also nucleus, vicinity of the nucleus. Ready. So just now I have drawn for one nucleus, quite similar to that, remaining also you can draw. So this is the nucleus. I hope you are observing. Say yes or no? Yes, this is the nucleus, okay. That's why this is the nucleus. At every nucleus just I am drawing this graph. I hope you are observing. This is the nucleus. This side and this side. This is the nucleus. This side and this side. Okay. So if you just combine this just like this. Now what happened? Here at the nucleus, in the vicinity of the nucleus, you got a potential well, and after that you got a potential barrier, and again potential well and a barrier like this. So this is the vicinity of the nucleus. The electron is bounded to the potential well, okay, and after that we are having a barrier, and it is crossing the barrier and again going to the potential well. So it is moving in either a potential well or a barrier. So what we are assuming is, we are assuming, let in the vicinity of the nucleus, electron is free. And the barrier outside height, I am taking it as V naught. How much? That's it. Because this is the barrier height. And I am assuming this electron potential energy is 0. That's why whatever you are studying, this is called nearly free electron theory. Sir, why this word is taken? Because we are assuming again in the vicinity of the nucleus the electron is free. That is the assumption we are taking to study. Without any assumption we can't proceed. Ideal case always we will study after that we can implement. Is that clear? So I hope everybody understand what exactly happening in the lattice. So this is the free electron and the energy we got continuous. That is wrong. Okay, if it is a continuous, all the solids must be conductors. All the solids must be conductors, but it's not correct. But some solids are conductors, some are semiconductors, some are insulators. So what's happening here? Maybe some energy bands are forming. What is the reason for that? Then whatever you assumed is wrong. The actually electron is not at all free completely. So it is moving in the periodic potential of the lattice like this. And that too, one more assumption we made. In the vicinity of the nucleus, again we assumed it as a free particle. That means just like a free particle in a 1D box. Clear? Come on. That's why band theory of solids is also called as nearly free electron theory. Not completely free. So in the vicinity of the nucleus we got the potential well, and after that we have potential barrier. So this is the potential well, and this is the barrier. So finally we are going to show that how there exists a discontinuous in the energy bands. Okay, it's not at all continuous, there must be some discontinuous. Let us see. So one more assumption we made here, in the vicinity of the nucleus, electron is assumed to be free. That's why it is called a nearly free electron theory. So finally, in the band theory of solids, we are assuming the electron is moving in the periodic potential of the lattice. How that potential is varying? 0 in the vicinity of the nucleus, outside the vicinity V0, some potential barrier. So 0 V naught, 0 V naught, like that. So periodic potential. Let us see. Ready? Right. Stop. Okay. So now this is the assumption in the band theory of solids. We are assuming the electron in the vicinity of the nucleus is free, but outside the nucleus it is not free, bound particle. Listen. So this is our lattice. Okay. Now I am considering this is the nucleus, of course. So here we have the potential well. Say yes or no. Okay. Now listen, Babu, very important. I am taking the potential well, and after that we have a potential barrier. Oh, we have to take a little bit far. Okay. So now I am taking in the vicinity of the nucleus what you are having a potential well. Say yes or no. This is the vicinity of the nucleus. Here somewhere. So again beyond the nucleus, I mean outside the nucleus we have potential barrier, and again potential well in the nucleus vicinity, potential barrier, well, something like this. It's a keep on varying. Cool. Now I am assuming this is the potential well. Anything you can take. Shall I take this one? Yeah. Potential well. I am taking this is the potential well. That means here we have the nucleus vicinity. I am taking this is a 0 and A. That means I have taken width of the well as A. And this is the barrier. Listen carefully. Barrier potential V naught. I am taking this width as B. 0 minus of minus B. B. Understand? What is the width of the barrier? B. What is the width of the potential well? A. That's good. If this is the 0 to A, this is what? Barrier. Barrier height is what? Yeah. 1 second. Barrier width must be B. Yes. This is already A, that's why. Yes. Understand? Next one. This is the potential well? Yes. Potential. Zero. Potential. Zero. Now, potential well width. A. That's why it is already A plus B, that's why. Yes. Everybody understand these points? Like this. Cool. Now carefully observe. Your potential is varying periodically. So what is the periodicity? First find this. Potential is varying periodically. Now what is the periodicity? Now carefully see. Love you. Is it a well? Yes. What is this side? Zero. Zero. Now again the first end of the well is here. Say yes or no? Okay. So your potential, and one more. This end, second end is at A. And second end of the well exists again at A. That means your well potential 0, V equal to 0 exists from 0 to A, 0 to A, and again exist from A plus B to your potential 0 exists from 0 to A to 0 to A and A plus B to, that means 0 become A become after what interval it's a repeating value. That's it. I hope everybody understand. So the periodicity is nothing but how much? That's good. So we can say one thing. This is the periodic potential with periodicity. What is the periodicity? This is definitely again equal to what? P of x. So your electron in the lattice is moving in the periodic potential of a periodicity. That's good. One minute. Okay. So fine, very good. But the problem with this model is what? We have to find the wave function of the electron. We have only one choice, that is the Schrodinger equation. We can't find Schrodinger equation each and every region. How many Schrodinger's equation you will write? 10 to the power of 23 you will write? No, it's not possible. That's why here what we are going to do. Are you ready? Right. Now we have to take the Schrodinger's equation. I hope everybody understand this diagram. What is happening here? This is the first end of the potential well, and again repeating at this point. That means after A plus B. So every x is repeating after x plus A plus B. I hope everybody understand this point. Am I right? Good. That's why your potential is a periodic potential with the periodicity A plus B. Now I have to take the Schrodinger equation. Let us start. Schrodinger's equation. Before going to enter into this periodic potential, let us go back to the free particle and again we will discuss that. Wait. Now I am assuming free particle, free electron. What is the potential? Zero. Everybody say. Now come on. What is the Schrodinger equation? Dou square psi by dou x square plus 2me by h cross square psi equal to? Good. Now I assume this thing is nothing but what? K square. Am I right? That's why we will write psi of x is nothing but, is it a plane wave? Say yes or no? Good. It's a plane wave. Okay. The solution of Schrodinger equation of a free particle. What is the solution? Plane wave. What is that plane wave? Now, but actually our electron is moving in a periodic potential. Am I right or wrong? Periodic potential of periodicity A plus B. Then what to do? Here we are going to introduce Bloch's theorem. What is that? Bloch's theorem. So what is the use of Bloch's theorem? If you know the solution in a particular region, you can get the solution after the periodicity. For example, you know the potential, you know the solution from 0 to A. After the periodicity, which region you are getting? This solution you can find by using Bloch's theorem. So Bloch's theorem is simply gives you the Schrodinger equation solution of a particle moving in periodic potential. 1 minute. This gives the solution of Schrodinger's equation, Schrodinger equation of a particle moving in periodic potential. So what is this Bloch's theorem? Are you ready? The Bloch's theorem is given by psi of x equal to, what is that? This is the solution of Schrodinger equation of a particle moving in periodic potential. Clear? Now I am assuming, because this is the theorem, not the problem, I am assuming periodicity is A. Periodicity is how much I am taking? A. That means, come on, say V of x plus A equal to V of x. I am not doing the problem. I am explaining the Bloch's theorem. I am assuming the particle is moving in this potential with periodicity A. Then what is the solution? Are you ready? Psi of x equal to uk of x into e raised to sorry. 1 minute. Psi of x equal to uk of x into e raised to I k x. 1 minute. uk of x equal to e raised to I k x. 1 minute. So what is this? This is called Bloch function. Wait. What is this? Solution. Earlier free particle solution, something solution. This is the solution of showing us equation. Listen carefully. So psi of x equal to uk of x into e raised to I k x. Now this Bloch function uk of x having periodicity of the lattice or potential. So that means if you substitute uk, what is the periodicity you have taken? A. uk of x plus a equal to uk of x. So if you want to find the solution after a, that means psi of x plus a equal to uk of x plus a into e raised to I k x plus a. This is having periodic property. Again it is coming uk of x into e raised to I k x into e raised to I k a. But what is uk of x into e raised to I k x? Your psi of x. Finally what happened? Psi of x plus a equal to psi of x into e raised to I k a. Once again see. This is the Bloch's theorem. Bloch's theorem is simply, if you know the solution in one region, you can get the solution in another region after a periodicity. You know psi of x. I want to find psi of x at x plus a. Clear? Once again see. Just remember, this is not derived. We can't derive all these things. Okay? Just remember the statement. What is the Bloch's theorem? Psi of x equal to uk of x e raised to I k x. 1 second. So this is the plane wave. Earlier whatever we have assumed, if it is a free. So that is a free wave, plane wave, that is a free particle solution. So if a particle is moving in a periodic potential, they introduced a small function called a Bloch function. What is that Bloch function? That Bloch function is having or periodic properties of the lattice. What is that? uk of x plus a equal to uk of x. Wait, what I am saying is, this is my solution at a particular region. Now I want to find the solution after a periodicity A. Come on. Psi of x plus a equal to uk of x plus a e raised to I k of x plus a. Please split it. E raised to I k x into. Now uk of x plus a equal to. Then uk of x into e raised to I k x is nothing but. That's it. So psi of x plus a after a periodicity a equal to psi of x into e raised to I k a. Now come to this. What is your periodicity? Now I know the solution psi. I want to find the solution after a periodicity a plus b. Tell me psi of x into e raised to I k x plus b. And then over. That's it. That's the Bloch's theorem. It simply tells you, if you know the solution in one region, after a periodicity, what could be the solution of Schrödinger's equation. Understand? Still not understanding? We'll explain. Come on, write down. Always remember one thing in physics. Whenever you are discussing a new thing, always they will modify the old one. This is the free particle wave function. They multiplied with the Bloch function. What is your doubt? Stand up. Why you are asking him? Don't have manners at all. What is your doubt? Ask. He knows. He came to teach here. Ask. Did I solve anything till now? Then why you are asking? Did I apply Schrodinger equation till now? Then why you are asking? I didn't apply any Schrodinger equation to this. Did I apply? Sit down. I have not taken any Schrodinger equation for this. Then why you are talking about that? This is I have written free. Okay, this we know. Now we want to get the solution of a particle moving in a periodic potential. That is I am explaining. I clearly said you won't listen properly. I am not doing the problem. This is what I said. Without listening properly, simply asking. On that day also I clearly tell. In the textbooks they will write multiplied, but I am taking doublet because of it is a single electron. Alkali atoms we are studying. No, you have to listen properly. Maximum, if you are listening properly each and every sentence, you won't get the doubt. If you are getting a doubt, I am waste. That means I didn't explain properly. That's why each and every point I will explain while I am explaining. You people won't listen properly. What we will do? Mind ekkado untundi, absent. I clearly said I am not doing the problem. We are explaining the Bloch's theorem. I don't want to get any student doubt while explanation is going on, because I want to explain what is this, what is this. I am clearly explaining in the order. And you are jumping to the next step. What I will do? It's not correct. Wait, after that ask. So the Bloch's theorem is just an idea to get the solution of Schrodinger equation of a particle moving in a periodic potential. Because we know the solution of a free particle that is modified with Bloch function. That Bloch function is having the property of periodicity. Focus on what I am explaining. In your mind, if you are thinking something else, waste to sit in the class. What I am explaining, focus. That's enough. very important, Bloch's theorem gives the solution of Schrodinger's equation, moving equation of a particle moving in a periodic potential. In the theorem, I am assuming this potential. I am not doing the problem. Again, I will come back to the problem. Just wait. To understand Bloch's theorem, again I have taken some potential of periodicity A. We are searching what theorem will explain the solution. If you know the solution, I want to find solution here, 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 everywhere. But I can't solve these many times. And similarly, if you know the solution here, you can get here, you can get here, like that. So what is the Bloch's theorem? It's a just modification of the free particle solution with a Bloch's function. That Bloch's function is having a property of periodicity, whatever the periodicity of lattice or potential. Periodicity of potential. Slowly understand. Ready? Ready? Yeah. Right. Once again, listen. We don't have any Schrodinger equation solution readily with us. If you know the solution here, after repetition of space and periodicity. Again, we can't solve the Schrodinger equation. Like that, if you want to solve infinite Schrodinger equations, you have to solve. That's why we are searching for any other thing. We go have a Bloch theorem. So what this Bloch's theorem is saying, listen. According to the Bloch theorem, the wave function of the Schrodinger equation psi of x of a particle moving in a periodic potential equal to, they have taken plane wave. This is the free particle. Are you observing? This is the free particle solution. Free particle solution. And just it is modified with a function called Bloch function. This is the free particle solution e raised to ikx. Example we are taking. If it is moving in a potential V, you know how to solve that. You know that? Energy greater than V, energy less than. I am not entering into the problem. Please listen. Okay. And this is the Bloch function. Still, if anybody didn't understand, please listen. Bloch function. This Bloch function. Sir, where you have introduced that periodicity? This Bloch function is having the periodicity. What is that? UK of x plus a equal to UK of x. Is it clear? Now see. Okay. For example, I would like to find the solution after a periodicity A. That means x tends to x plus a. Then psi of x plus a equal to UK of x plus a e raised to x plus a. This is what I am saying. Listen. Okay. This is already having the periodic property. Now it is e raised to. This is the wave function after a periodicity A. This is nothing but so this is the solution in a particular region after periodicity, and this is the solution, known solution into e raised to I k a, where a is what? That's it. And this is the wave function after in a region after periodicity A, and this is the known solution. Now come to our problem. This is Bloch's theorem. Everybody understand? Sure? Yes, good. Now for example, I know the solution psi of x. After a periodicity B, what is the solution? Psi of x. Ante. That psi of x is the known solution which you solved by using Schrodinger equation. Everybody any doubts, ma? Now come to the problem, Babu see here. Okay, it's very clear. We have potential barrier and potential well, again barrier, potential well, like this. This is the 0, this is a V naught, this is a V naught. Now we are studying our electron is moving. Definitely its energy is less than barrier potential because the nuclear potential is very high. So whatever the electron is moving with some kinetic energy, definitely less. How do you know, sir? Beta decay. In the beta decay, the electron which is coming out of this atom is how much? 7 to 8 MeV. 7 to 8 MeV. Okay. So 7 to 8 MeV kinetic energy, which is very less compared to the nuclear potential energy. So that's why the energy of the particle is less than V naught. Here we have taken potential is 0. Come on, this is a 0, A minus B, A plus B. Am I right? Okay, enough. Now first I am considering this. Now I am applying Schrodinger equation to the problem. Now first one, 0 less than x less than a. I am going to find the solution. Now here the potential is, come on, Schrodinger equation. Now I am assuming this as alpha square. That's why, shall I write the solution plus or minus a? Here plus or minus a? అది కూడా చెప్పరు, అది కూడా స్లోగా చెప్తారు. ప్లస్ దెన్ ద సొల్యూషన్ సైనసాయిడల్ ఎక్స్పోనెన్షియల్ psi equal to a e raised to alpha x plus b e raised to minus alpha x. అదే ikx minus ikx. Here we have taken as alpha square. Over. That's good. Second one, I am taking minus b less than x less than 0. Now this is the region we are studying. Our potential is V naught, but unfortunately less than E, energy of the electron. So Schrodinger's equation, dou square psi by dou x square plus 2m E minus V naught. But this is a negative. That's why what we will do, minus, directly I am writing because you know already. This is not quantum mechanics. V naught greater than E. Come on. 2m V naught minus E by h cross square psi equal to 0. Now I am assuming this entire thing as beta square. Okay, then the solution exponential or sinusoidal? C e raised to beta x plus D e raised to minus beta. Now your doubt is clear? This is a solution. Now tell me. Where? కొంతమంది జనరల్గా హౌ ఇట్ విల్ బి ఫ్రెండ్షిప్స్ రిలేషన్స్ యాజ్ లాంగ్ యాజ్ యూ లైక్ ఎనీ పర్సన్ ఆల్దో హీస్ కోల్డ్ ఆల్దో షీస్ కోల్డ్ వీ వోంట్ మైండ్ ఓకే impression, that is called impression. Your best friend, you fighted, next day what you will do? Again you will, because you like them so much. If you don't like one person, whatever he say you won't like. It's a true. Relations, anything. If you are sitting in the class with a negative mindset, it will be like this only. I don't know how many of you observed. My intention while I am explaining, no student should get the doubt in the explanation. Yes, I don't know how many of you observe, while I am explaining, in the meanwhile I will ask, shall I ask a doubt, shall I ask a doubt. All those doubts are asked by the earlier students, earlier batches. Because while I am explaining, one student got a doubt means, maybe next batch also some students will get the same doubt. If it is a valid, I will explain. If it is a not valid, we won't explain. If you don't like a person, although he didn't say anything, he didn't scold, but you feel he scolded us. That's the point. That means those people sit on a branch and they will cut their own branch. They will understand after few years. Come on. This is the just showing us equation solution of the given potential barrier or given periodic potential. And one more thing, our periodic potential, what is this? V of x plus AB equal to V of x. If you listen with 100% concentration, I will explain each and every point. Maybe I won't give the notes, but I will explain. Maximum while you are solving the problems only you will get the doubt. After explanation also, if you are getting doubt means I didn't explain properly. One more time I am reminding you, whatever we are doing is what? The nearly free electron. That means what is the assumption we made? In the vicinity of the nucleus, electron is assumed to be free. Please remember that. Free mind and sit in the class. If you are thinking something different, you won't understand what I am explaining. Sit down, sit down. First make your mind free and sit in the class. After that read. Sit down, sit down. Right. One more time, please see that Bloch's function, Bloch's theorem. Bloch's theorem will tell you, if you know the solution of Schrodinger equation in a particular region, if anybody asks, what is the Bloch's theorem? Don't write psi of x equal to uk of x e raised to ikx. Please tell them, if we know the solution of Schrodinger equation in a particular region, after the periodicity of the potential, or a region after the periodicity of the potential, we can say the solution. Simply earlier solution into e raised to ik periodicity. Now please listen. Stop writing, Amma, please. Listen please, listen please. Okay, cool. So here potential 0, we know the solution. Sinusoidal. Potential V naught, of course, energy of the electron is definitely less than V naught, and we got this solution, that is exponential. Now, everyone see, I would like to find the potential in this region. Okay, so here the potential is V naught, and again repeated V naught after an interval of minus B A, that means A minus of minus A plus B, otherwise 0 A plus B minus 0. Everyone understand? So this is the region having the periodicity of x plus, say yes or no. That means V of x plus A plus B equal to, according to Bloch's theorem, listen. Bloch's theorem, the wave function after the periodicity x plus A plus B equal to psi of x, this is the known into e raised to ik periodicity. So what could be the solution in this region? So in this region solution, psi of x equal to known solution. Emma, understand? In this region you know the solution. In this region we are finding the solution. Known solution into e raised to ik of. So that is your solution after the periodicity A plus B. Understand? Is it clear? Any doubt? Psi of x written. That is in this region. Okay, I will give the numbers, just wait. Okay, fine. K, not beta. K, plane wave, K. Here beta we defined something else. Okay, no, K only. Ready? It's not beta, it's not alpha, it is K only, or maybe alpha. Maybe alpha but not at all beta. When it is alpha, I will tell you, please wait. Ready? Stop. So his doubt is, okay, valid doubt. He got a doubt here. Is it a beta or k? So it's a k only. K means what? Under root 2me by h cross square. It may be alpha. When it will be alpha, just wait. But it is not at all beta. Because Bloch's theorem contains the solution of a free particle. From that only we derived. Is that clear? Good. So it's a k only, not at all beta or not at all alpha. Is that clear? Right. Now once again, I am taking at x equal to 0. At x equal to 0. X equal to 0 means this one. This is my psi 1 and this is my psi 2. I am taking the boundary conditions. Now first one, psi 1 equal to psi 2. Where? Psi 1 you know, psi 2 you know. Come on, say a plus b. Put x equal to 0 in psi 1 and psi 2. C plus next second one, differentiation. Dou psi 1 by dou x equal to, very few people are saying, at x equal to 0. Now once you differentiate this, I alpha, am I right? I alpha, a minus b, and this is beta, see, that's good. So a minus b equal to minus iota beta by alpha c minus d. Equation 1 and equation 2. You can rearrange this. Once you, okay, you will get 4 equations. A plus b equal to c plus d, and here a minus b equal to this one. Like that, one more boundary you have to take. Shall I take x equal to a? X equal to a. Ready? X equal to a. X equal to a, this is my psi 2. Let us say this is my psi 3. Now it's okay? Ready, start. Psi 2 at x equal to a. X equal to a. A e raised to alpha a plus b. Good. Equal to just psi c e raised to beta a plus d e raised to minus beta a into plus. Next one, second condition, differentiation. Shall I do it? If you do the differentiation, I alpha, come on, a e raised to I alpha a minus b e raised to minus I alpha a. Slowly. Now this is a beta c e raised to beta a minus d e raised to minus beta a into e raised to I k. That's it. We got 4 equations, 1, 2 and 3 and 4. Okay, fine. Then what to do next? We have to solve these equations. Solve these equations means trivial solution is all coefficients a, b, c, d all are 0. So non-trivial solution. Non-trivial solution. That means what I will take? Coefficients of determinant a, b, c, d equal to 0. Just take the coefficients of a, b, c, d and take the determinant is equal to 0. 4 equations are there now. Take the coefficient of a, for example, 1. Next, 1 c also this one. This one, 1 minus 1 minus 1 by alpha c minus d. Is it okay? But what about that? Where you will write that? You have to take the coefficients of a, b, c, d, determinant 0. You have 4 equations. Where you will write? That is my doubt. Two determinants, no. Wait, if you add this, what you will get? A in terms of C and D. If you subtract, what you will get? B. If you add that, there also you will get no, nothing you won't get. Oh, 4 by 4 కాదు 2 by 2 4 by 4 మ్యాట్రిక్స్ కాదు 2 by 2 ఎస్ఎస్పిలో 4 by 4 ఆడదని అబ్బోందా 4 by 4 no 2 by 2 only I think. Okay, come on, right. How we will take? We are not solving this. We are not solving, just I am saying coefficients of A, B, C, D. How we will take? We have to add ones, subtract ones, add ones, subtract ones. Then you will get here A, B, and there also you will get AB in terms of CD. You will get AB in terms of CD. Then what you will do? Yeah, here also you will get. You can bring I alpha this side. In the quantum mechanics also we will do the same thing. We will bring that and we will add ones and subtract ones. Any textbook is, do you have textbook? Please check. He didn't solve, he has written that determinant. We are not solving actually. 4 by 4 written, oh 4 by 4, sorry. 4 by 4, correct? Okay. So 4 equations A, B, C, D, 4, yes, A1, B1, C1, D1, A2, B2, C2, D2. I thought that it's only 2 by 2. No, sorry. C3, D3, A4, B4, C4, D4. Please check the answer. Alpha square plus beta square by 2 alpha beta. Sin hyperbolic alpha A cos alpha square beta square minus alpha square by 2 alpha beta. What he assumed alpha and beta, check that also. Maybe I am not following that book. Same. Final expression will be there. Alpha square plus beta square by 2 alpha beta. Sin hyperbolic alpha A something hyperbolic in terms of hyperbolic sin not there. Okay, leave it, right. Huh? Alpha square plus beta square by 2 alpha beta sin hyperbolic అదే, and they will take it as a P, that alpha square plus beta square by 2 alpha beta, they will take it as a P. Finally a graph will be there. Okay, come on. Okay, Bob, that's it. Here 1, 1, minus 1, minus 1, and the same thing 1 and like that. So take the coefficients of ABCD, ABCD. It's a 4 by 4 matrix determinant. Somebody said sum of 2 by 2 determinants. 4 by 4. No, in my notebook I have written 2 by 2. That's why I'm getting out. We are not solving the determinant, okay, don't worry. After finding the determinant, the value I will tell you. So the non-trivial solution determinant is equal to 0, determinant of coefficients equal to 0. Why that confusion? 4 equations, 4 coefficients, 4 by 4. Ready? Right, stop. So we are not solving the determinant. Finally, I am writing what is the expression you will get after finding the determinant and equate to 0. Everyone listen. So once you have taken the determinant, you will get like this. This is also no need to remember, don't get tension. See one more time, my intention is to simply show that how we are getting energy band gaps. That means one continuous band will be there, after that forbidden, again continuous band will be there, again forbidden. That is what I want to show, okay, right. Alpha square plus beta square by 2 alpha beta into sine hyperbolic, I think sine hyperbolic beta, yes, sine hyperbolic beta b cos alpha a plus cos hyperbolic beta b into cos alpha a equal to cos ka. Not exactly cos ka, cos k of a plus b, I think. So this is the expression you will get. If you want derivation, see the textbook. Textbook also I think they have written determinant, and after that they have written, I think. Okay, fine, no problem. So this is the expression. Everyone please stop and see the board. Now once again, alpha square plus beta square by 2 alpha beta. Here is the sine hyperbolic, cos alpha, cos hyperbolic, cos alpha, cos ka. Otherwise there are some websites who will give you the determinants of anything, any matrix, eigenvalues, eigenvectors. Just open that and give these values and check what is the determinant you are getting if you are interested. But whatever the book it is given, I have taken. Now let me find this. I hope we have defined alpha square equal to 2me by h cross square and beta square equal to 2m v naught minus e by h cross square. Once you add, e gets cancelled. I think that alpha square plus beta square will be equal to how much? 2m v naught by h cross square. So yes or no? Okay. And And after that what we can do is, we are taking an approximation. We are taking an approximation. Here something is missing. Correct, 2 alpha beta. Okay. Here we are taking an approximation. What is that approximation? Listen. Earlier we have taken, this is the potential barrier height V naught, and the length you have taken B. Yes or no? Here we are taking an approximation again. B tends to 0, V naught tends to infinity. Of course, such that B V naught is again finite, because this is the barrier height. I am assuming again it is of infinite height, because the electron energy is very less compared to the barrier potential, and this B is what? Tending to 0. That is why this B V naught is very, very small. Is that clear? Good. So, once you have taken B tends to 0, all of you please observe that B tends to 0. Then sine hyperbolic, I hope you are observing, sine hyperbolic. If theta tends to 0, sine theta is also nearly equal to theta, sine hyperbolic is also nearly equal to theta. Now, what is the answer? Yeah. Next, beta tends to 0, we are taking this approximation, beta B is nearly equal to 1, not 1 minus theta square by 2, we are taking it as a 1. If you take it and substitute, alpha square 2m V naught by h cross square into 2 alpha beta, slowly, sine hyperbolic beta, beta B, come on. Next, cos, this is taken as into 1, cos alpha in equal to cos Ka. B tends to 0. Now here, with your permission, I will multiply with okay, beta gets cancelled. Okay, so this term I am multiplying with A here, and here also I will get A. Finally, 2m V naught, what is this? AB by 2 h cross square, 2 gets cancelled if you want. H cross square alpha A, don't cancel A. Why, sir? They are taking some A B using for some other purpose, just keep it as it is, into cos alpha A plus cos alpha A equal to cos Ka. Shall I take cos alpha A common? Don't take. I am assuming this as some parameter P, because M constant, V naught constant, this one constant, alpha, whatever it is, fixed value. A is the width of the barrier, AB is the product of width and 2 widths. So let us suppose P equal to M V naught AB by h cross square alpha A. Then finally what I get, come on, P cos alpha A plus ఏదో ఎక్కడో నో అసలు సైన్ పార్ట్ ఈజ్ మిస్సింగ్. Is it cos alpha A, sin alpha A? I have given wrong. Sin alpha A, not cos alpha A. Once again, alpha square plus beta square by 2 alpha beta, sin hyperbolic sin alpha A plus cos hyperbolic cos alpha A equal to this one. It's not a sin cosma, it's a sin. That's good. Yes, now I understood why they have taken this. It's okay. So now this mv naught ab by h cross square, let this p equal to mv naught ab by h cross square. That implies, yes, I remember the final expression. I should get sin theta by theta. That is not coming. So maybe I have given here wrong, amma. So please correct it. P sin alpha a by alpha a plus cos alpha a equal to cos ka. Thanks. This expression will tell you where we will get the energy band, where we will get the forbidden gap. How it explain? I will explain. Just wait. Come on. Don't expect the complete derivation. Leave it. Just write the expression final. This is the sine hyperbolic sine, cos hyperbolic cos. After that, this is the approximation we are taking. B tends to 0. Now just take it. Here small confusion. By mistake I have taken cos alpha a. Sorry. Please correct it. Sine hyperbolic theta is a theta, cos hyperbolic theta take it as a 1, and then we got the final approximation p sin alpha by alpha a plus cos alpha a equal to cos ka. Shall I ask one question here? Everyone please see. V naught you have taken infinity, B you have taken tending to 0. That's why this P value is a small or a large. Okay, just remember that. You have already defined B tends to 0, V naught tends to infinity, but BV naught is a finite. You asked earlier. Read that last equation. Put P equal to 0, tending to 0. So in that case only your K will become alpha, but K never be equal to beta. Don't bother about this derivation, no need, no use, okay. But approximation, remember, from that approximation we got this final expression. But always remember that P is very small. I try my level best that graph, it's a bit difficult to draw, but I will try. Ready? Stop. Listen carefully. Maximum try to understand. If not understanding, read the book. Maybe then you will understand. First, let me explain, please. So, this is the final expression. Everyone, please listen. P sin alpha A by alpha A plus cos alpha A equal to cos K A. Simple maths, not at all difficult. Listen, just listen. Please focus on this right hand side. What is that? Cos K A. Cos theta. Am I right? Cos theta, this one, what is the minimum value? -1. Maximum value? +1. Oh, your right hand side must be lying between -1 and +1. So, if the right hand side is lying, maximum and minimum values you fixed. Maximum value +1, minimum value. That's why left hand side total value also lie in between. Wait, this value also total value, try to understand, lie in between -1 and +1. So, it indicates that your input, you are giving values of what? Alpha A. Whatever the alpha A you are giving, that means whatever alpha A allowed, such that this entire value lie in between only those values of alpha A are allowed and the remaining alpha A values are forbidden. So, wherever alpha A value of this expression is giving -1 below and +1 above, all those values are forbidden. So, you are having the spectrum only between or only in a region of alpha A values of in which or for which we will get this entire expression value. If you didn't understand this statement, just once again read the book. Now see. Now I am taking the graph. This is the y-axis. I am taking P sin alpha A by alpha A plus cos alpha A. I am taking that value. Is it clear? Because this value definitely lie in between +1 and now I am taking somewhere 0, or is it? Now this is my alpha A x-axis. Okay. So now I am giving the input is alpha A x-axis and the value is what? P sin alpha by alpha A by alpha A cos alpha A. Clear? Are you understanding? This entire value lie in between +1 and -1. Try, please try. Whether you understand or not, just listen first. Let me explain. That's it. Okay, cool. Ready, start. Alpha A is nothing but the angle. That's why I am taking, this is a 0 and somewhere I am taking pi by 2, somewhere pi by 2, somewhere pi, next 3 pi by 2, next 2 pi, next this side minus pi by 2, minus pi, minus 3 pi by 2, something like this. Is it okay? Now carefully observe. If alpha A is tending to 0, then this value equal to 1, that is nothing but P. Still we have taken P is very small. Say yes or no? That is what we are discussing till now. P is tending to 0. That's why, which is the dominating value? So, whatever the allowed region it will be decided by cos alpha A. Cool. Now ready? Ready? One more time I am saying. As alpha A is tending to 0, okay, this value is 1, so that is why P plus cos alpha A. I am taking that P is tending to 0. What is the reason? I already explained there. Tending to 0, very small. That is why the left hand side value is dominated by. Now ready? Carefully observe. Now these are my 0, pi by 2, pi, 3 pi by 2, 2 pi something. Now this is, forget about this. Only dominating is what? Cos alpha. Okay? We are not finding exact values, approximations. Now ready? So cos pi, alpha A equal to pi, cos pi minus 1 or plus 1? Observe. Next. So cos alpha A is tending to pi by 2, then this value will be 0. And alpha not exactly at pi, close to pi, understand? But I am taking like that. And again it is coming close to 0, somewhere, cos alpha A 0, how much it is? Say yes or no? Somewhere. Okay, that means plus 1, again it becomes 0, again it becomes minus 1. And around at pi it is becoming minus 1, close to 0 it is going to plus 1. Understand? Everybody? Similarly, left side near to 0 it is going to plus 1, and exactly not pi, nearly at pi it is becoming minus 1. Is it okay? Now many times I told you, we will first explain only first Brillouin zone. If you observe carefully, where it is going to minus 1 means it is a pi by A, alpha A, then alpha is what? And this is also, so minus pi and plus pi is which region? That also understand. Didn't understand? Alpha A is pi means alpha is what? Pi by A. Wait. Okay. Once again. What happened here? As alpha A coming close to 0, it is going to plus 1. As alpha A is going towards pi, not exactly at pi 9, nearly. Coming close to pi, that is a zone boundary, you are getting a minus 1. So definitely your energy spectrum lie in between plus 1 and okay, slowly. Next, ready? One more we will take. Ready? So 2 pi, cos 2 pi, forget about this, this is nearly equal to 0, cos 2 pi, 1 plus 1, and nearly coming towards 3 pi by 2, cos 3 pi by 2, 0. Is it okay? Next. Come on. Again coming towards pi, it will be minus 1. Now only we are having this is allowed. That means if you extend this, carefully observe, here this is the allowed energy band, this is the allowed energy band, okay, but here we are getting beyond minus 1, is it allowed? That is why this is what? Forbidden. Similarly, from here to here allowed, from here to here allowed, so that is why again I am taking, sorry. Now beyond this what is happening? Above plus 1, is it allowed? Okay. Still not understanding. In the same way, if you proceed like this, somewhere here nearly minus pi, you will get minus 1. And again here what you are getting a forbidden gap like this. So, what is happening here? So, this is origin of course, okay. Somewhere very close to the origin, we are having this energy band. This is the allowed energy band. And nearly at the zone boundary, please see this, because exactly we won't get it, it's impossible. Nearly to the zone boundary, we are getting a minus 1. That means beyond minus 1, no energy is allowed, because these values are not allowed. That means in this region, what we are having? Forbidden. These values are forbidden, and this gives you a forbidden gap. And this is the allowed, and this is also allowed, and again here we have forbidden. So, this is the structure what we are getting in this diagram. In this diagram means we have taken x-axis is alpha A and y-axis is this, but still we are not getting a clear picture. That is why we will take this diagram and draw in the reciprocal lattice, and there we will see what will happen. There you will understand. So, how the energy bands are getting, and at zone boundaries what we are getting. From this diagram, my intention is to say that near to the zone boundaries we are having forbidden energy gaps. This equation is telling you near to the zone boundaries we are getting forbidden gaps, because only particular values of only particular values of alpha A only allowed, and after beyond that, that means this is the region where alpha A gives this value beyond minus 1. That is why this region is forbidden. Similarly, this region is forbidden. Similarly, this region is forbidden. Like that we are getting allowed energy, forbidden, allowed energy, forbidden. But here we are not clearly understanding how that structure will be. That is why again we will take this and represent in the reciprocal lattice. First write down. I will give some points here, maybe it will be useful. Still not understanding, please write those points. One thing I want to say here, the energy spectrum, how it is, alternate energy allowed bands. That means allowed energy band and forbidden, and allowed, forbidden, like that. Earlier we got what? Continuous. So, now it is discrete, and there exists a forbidden gap between two allowed bands. That is important. Sir, how we will draw this? Just to forget this term, then where this term is becoming plus 1 and minus 1. Minus 1 is becoming at pi. That is why very close to pi. As it is approaching to pi, it should go to minus. Next, where it will become plus 1? 0. So, it is approaching to 0, it will go to plus 1. This is called zone boundary. So, at zone boundary we are getting forbidden gap. Slowly draw. We won't get any question, but we should know now at least how we are getting that, what is the mathematics there, at least. Although derivation is not understanding, just in the beginning how we proceed, what is the approximations we have taken, potential well, how we got periodic, and Bloch's theorem. You must remember the Bloch's theorem because the question will come on Bloch's theorem or Bloch's function. So don't forget that. And this derivation no one will ask. This is only helping you at the zone boundaries why we are getting forbidden gaps. Somewhere I explained in the X-ray diffraction or somewhere at the Brillouin zone boundaries we will get the diffraction phenomena and the wave become standing wave, and we have shown that group velocity is equal to 0 there. There I explained it become a standing wave, that means it is not transmitting any energy, and I said at that boundary you will get a forbidden gaps. We will understand why we are getting in the why we are getting at the zone boundaries. We will explain in the band theory of solids. This is what I said on that day. So this is the derivation. Near to the zone boundary, we are getting a forbidden gap. Please observe. Of course, this is origin. Please read about Bloch's theorem, don't neglect. Right on? First point. The energy spectrum of electron, here, first point. The energy spectrum of the electron consists of alternate regions of allowed energy bands regions of allowed energy bands. Next, second point. The boundaries of the allowed energy levels, corresponds to cos Ka equal to plus or minus 1 implies K equal to plus or minus n pi by A in bracket zone boundaries. Because cos Ka must take only plus or minus 1, maximum and minimum. Next point. As P tends to 0, the potential barrier becomes, zero, and the electron treated as, potential barrier becomes weak. And electron treated as free. Next point. As p value increases, the area of the potential well increases, and the electron is treated, bound to the electron is treated as a bound particle. Electron is treated as a bound particle. That's enough. Now listen. So finally what do you understand from that graph? We are getting the discontinuities in the energy spectrum where at the zone boundary. 1 minute. All of you please listen. Last, very important. So earlier we have taken electron as a free electron theory. If electron is a free completely, what we get already I have discussed, its energy equal to h cross square k square by 2m. Are you listening? That implies your energy is proportional to k square. So we got this spectrum. This is E, and this is what kind of spectrum it is, continuous. Wait. Now till now today what we have taken is electron as a nearly free electron. Nearly a free electron. This is what we have assumed. Say yes or no? And finally what happened? This is my reciprocal space. Everyone please observe. This is the reciprocal space. Now I am going to represent that in the energy versus K diagram. That is not energy versus K diagram. Where we are getting the discontinuities, that is only telling where at the zone boundaries. This is the K and I am taking this E. Everyone please listen. This is a 0. Pi by A minus pi by A, 2 pi by A minus 2 pi by A, something like this. Now everybody know this is my zone boundary, this is the zone boundary. So first let us, this is also a zone boundary. So according to that diagram, if you observe carefully, up to the zone boundary, what you are having a continuous spectrum. Say yes or no? Okay. So this is the origin and this is the zone boundary and the spectrum is like this. And here what we are getting? Forbidden. From that I hope everybody understand, near the zone boundary we are getting a forbidden. And again curve, that means I hope you are observing there we have drawn some lines, okay. So white color lines earlier. Sir, why you are carefully drawing the flat region there? Because at that point we are getting a standing wave whose slope must be 0 there. That's why it should become flat. And again, I hope you are observing. And sir, why you have taken concave here, convex here? Just wait, tomorrow. Ready? This one. Okay, again forbidden gap. Again forbidden gap, something like this. So here we are having forbidden, forbidden in this region, and this is allowed, allowed like this. So alternate allowed, forbidden, allowed, forbidden. This is what we understand from that graph. And if the same thing if you represent with energy versus K, the free electron it is a continuous spectrum, but in this nearly free electron theory what we got is alternate energy bands exist, alternate forbidden bands exist or alternate allowed energy bands exist. And tomorrow we will see. So what it will give the information and what is the effective mass and what is the velocity of the electron, why the velocity of the electron is negative or why it is decreasing. All these things we will discuss with the help of this graph. Only this graph will tell you the remaining part. Is that clear? Right. If you observe carefully, bottom and top parabola, this is a gate question. Which of the following is correct, incorrect, something like this. So, energy versus K in the band theory of solids, it is a parabola parabola at bottom and top of the energy band, but the curvatures are opposite direction. Curvatures are opposite direction, please remember. And here what you will get? Minimum. What you will get? Maxima. In between what you will get? Point of inflection. That point of inflection will tell you the Fermi level, and that Fermi level will decide you whether it behaves like a conductor or a semiconductor or insulator. Everything will come from this graph only. Okay, right on. I think I need not to say all these things. Slope. Here what is the slope? dE by dk. Slope how much? 0. At the maximum slope 0. That means dE by dk equal to 0. But this is a minimum. Minimum means first derivative. D square E by dk square. Again tomorrow I will explain. Just writing. Greater than 0. This is the maximum. That's why d square E by dk square is negative. Don't forget. And somewhere in the middle there exists a point of inflection. Point of inflection. I explained all these things. Okay. Point of inflection. Here also dE by dk 0, but d square E by dk square equal to 0. This is very crucial. And again we will discuss that graph, that curve tomorrow. What is the name given for this diagram in the in the textbooks? Extended zone scheme. Extended zone scheme means you need not to bother about all those things. You just only study about this first Brillouin zone. The remaining nature is repeated. So this is called extended zone boundary scheme. But my request, once read the book and leave it. Then if any points I didn't explain properly, that may fulfill. In the free electron we got a parabola, but in nearly free electron, top and bottom are having concave and convex, something like that. Okay, so curvatures in the opposite direction. That's why one is a concave, another is the convex. That convex part is the maximum, that concave part is the minimum. In the middle there exists a point of inflection. What are the significance of all those things tomorrow will explain beautifully. And tomorrow class is very crucial. Effective mass, everything will come here. Maximum tomorrow it will be complete, problems also, and day after tomorrow we have to start superconductivity. By Wednesday we have to close this, otherwise we will be in trouble. Thursday onwards we have to use this morning session for either SM or for digital, otherwise it won't be complete. Please read the book, he explained properly. Please read Wahab book and leave it, once read and leave it. Because before the interview if you read you feel unfamiliar. Now once you read and left, while you are revising for before interviews, you feel okay, I know this something earlier. Some confidence will be there. Otherwise what will happen generally, student psychology, if it is unfamiliar, what we will do? We will leave it. That's it. No, first read and again we can revise later. Don't neglect, please. That's it.